Okay, pre-calculus kids, today we're going to look at solving some equations. We're going to start with a really basic one that you guys all know how to do, just to review the steps, and then we'll get into ones that are a little more complicated. So if you'll bear with me, we want to solve this equation. And if I ask you guys what's the first step, you're all going to tell me the same thing. You're going to say subtract 4 from both sides. Remember, how do we know we're supposed to subtract 4? And the correct answer to that is because we see addition by 4, and that's what we want to get rid of. So we ask, what is the inverse of addition by 4? The answer is subtraction by 4. So the key to this is just finding the inverse and doing it to both sides. So I am going to go and I'm going to say, let's take and let's subtract 4 from the left side and let's subtract 4 from the right side. And you probably think I'm wasting my time showing all these steps, but keep in mind, the equations that we're going to be looking at are far more complicated than 3x plus 4 equals 10. So if we develop good habits for this equation, we'll have good habits for all of our equations. So the idea here is, whatever the left side is, we're just going to put it over here. And whatever the right side is, we're going to put it over here. So that's using the inverse of addition by 4. We're now going to simplify, and inverses will cancel when acting directly on each other. There's our plus 4 and our minus 4 next to each other. That's going to leave us with 3x equals 10 minus 4 is 6. So now the question is, how do we get rid of multiplication by 3? And the answer to that is the inverse of multiplication by 3, which is division by 3. Show division by 3 on both sides. Notice I don't care what the left and the right side are right now. I am just making sure I do the correct inverse on both sides. Now, once you've got the inverse, we're going to copy the left side appropriately and the right side appropriately. And now, as always, after we do our inverses, we're going to simplify. So these inverses are acting directly on each other. They're going to cancel. That's going to leave us with x. And over here, 6 divided by 3 gives us 2. So there's the answer we're looking for. So again, I know you guys get this, but let's make sure you understand it completely, because we're about to take it to the next level. And we're going to try to now solve this equation where we've got 5 raised to the x minus 3 equals 12. First step, not a big deal. You know to get rid of subtraction by 3, you've got to do addition by 3 on both sides. So there's our inverse. And again, we're just going to take that left side and we're going to copy it in. And we're going to take that right side and we're going to do the exact same thing and copy it in. So now we've got our inverses acting directly on each other. So those are going to cancel, that plus 3 and that minus 3. That's going to leave us 5 raised to the x. And now this is 12 plus 3, which is 15. And now you need to ask yourself, what is it we're trying to get rid of? Now, we don't want to get rid of the x. We're trying to get x by itself. So who is with the x? And when we look at who's with the x, the answer is 5. So how do we get rid of this 5? Well, it's not addition by 5. It's not subtraction by 5. Not division by 5. It's not multiplication by 5. How is that 5 attached? That 5 is an exponential base, and that's the key. So we've got exponential base 5. And the question is, what is the inverse of exponential base 5? And the answer to that is the inverse of an exponential base is a logarithmic base. So exponential bases and log bases are inverses. And that is the key to today's lesson. That's it. That's what you want to come away with. Exponential bases and log bases are inverses. So when I want to get this x up here by itself, what I want to do is I want to do the inverse of exponential base 5. And I hope you're listening, because for those of you who are going to be sticking with me, this is the most important thing you'll learn today. The inverse of exponential base 5 is log base 5. And that is the only appropriate way to say it. So to get rid of exponential base 5 on both sides, we want to do log base 5 of both sides. And the way we write that is exactly how we practiced earlier in the week. So we do log base 5 of something equals log base 5 of something. And now we're just going to copy that left-hand side, and we're going to copy that right-hand side. And now we are going to simplify. Well, now I've got exponential base 5 acting directly on log base 5. What that means is log base 5 and exponential base 5 cancel out. All we're left with is x. And on the other side, we've got log base 5 of 15 which at first you're not going to be super comfortable with, but it doesn't matter. That's the answer. We've isolated x, we've gotten it by itself, and the other side can be left with a function as long as we don't know how to simplify it. And we don't know how to simplify this because, again, this is really like asking, and go back up here, it's really like asking, what number do I put in this exponent to get 5 to turn into 15? I have no idea, other than saying it's log base 5 of 15. Now, I do know this. It is between 1 and 2, because 5 to the first is equal to 5, 5 squared is equal to 25, and we're looking for somebody that's going to go right in the middle. We're looking for someone, and I'll just space this out a little bit. We're looking for someone that when I take 5 and I raise it to this mystery number, the answer I'm going to get is 15. So there is no whole number there. In fact, we don't have a name for this number yet, at least not in what we're used to. So the name for this number is log base 5 of 15. That's the name of the number. He lives somewhere between 1 and 2. So if we were to put this on the number line, we'd have 1 here, we'd have 2 here, and then somewhere in between, okay, we'd have log base 5 of 15. And when we raise 5 to the 1, the output would be 5. When we raise 5 to the 2, the output would be 25. When we raise 5 to the log base 5 of 15, the output is 15. So this is our answer, okay? Hopefully that makes sense. We're gonna look at one more example. This one, there's a lot of fluff because, let's face it, as long as you know inverses, these problems are easy. The first inverse we want to do is we want to do something minus 3 because we want to get rid of this guy right here. So we're going to subtract 3 from both sides. Now by doing that, we're going to copy everybody else over. We're going to fill them in. And now we're going to simplify, and we're going to get that the plus 3 and the minus 3, addition by 3, subtraction by 3 are going to cancel out. So we're going to be left with 5 times 10 raised to the x minus 3. And now this is going to equal 45 on this side. So the next step is to get rid of multiplication by 5, and the inverse of multiplication by 5 is division by 5. So here is division by 5 on the left. Here is division by 5 on the right. So here we go. We're going to put that on the left-hand side. We're going to put this on the right-hand side. And now inverses acting directly on each other are going to cancel out. So we've got multiplication by 5 and division by 5 going to cancel. And we're left with 10 raised to the x minus 3 equals, well, 45 over 5 turns into 9. Now, normally this is where you would try to play the common bases game. There are no common bases here, so we have to use inverses. So you're asking, what is the inverse of exponential base 10? And the answer to that is the inverse to exponential base 10 is log base 10. So we're going to do it to the left side. We're going to do it to the right side. So we fill in our left. We fill in our right. And now on the left-hand side, we have exponential base 10 and log base 10 acting directly on each other. They are inverses acting directly on each other. So log base 10, exponential base 10 cancel out. We are left with x minus 3. And on the right-hand side, we have log base 10 of 9. Again, not a number you're super familiar with, but remember, this is the guy that if we take 10, this is the exponent that makes 10 into 9. That's what this is. So what is the mystery exponent that turns 10 into 9? It's this guy right here, log base 10 of 9. That's his name. So last step, we're going to get rid of a subtraction by 3. And the inverse of subtraction by 3 is addition by 3. That's going to get us the following. So now we're going to put the left-hand side in where it belongs. And we're going to put the right-hand side in where it belongs. And we are going to simplify both sides. So my negative 3 and my positive 3 cancel because they're inverses being applied directly. That leaves me with x equals, and I'm just going to write the 3 in the front. I like that being in front so you don't get confused thinking it's part of the logarithm. And this would be our final answer. Okay, so the whole idea here is to use inverses. And again, the take-home message for today, the inverse of an exponential base is the corresponding logarithmic base. So please get used to the idea of writing something like this. Log base b of the left side equals log base b of the right side, because log base b is the inverse of exponential base b, and whatever the b value is, you can use this to figure it out. Hope that makes sense. There is a short homework assignment attached to today's Google Classroom. 6 problems. Please give them a shot. Feel free to email me if you have any questions. We will meet again on either Wednesday or Thursday, depending on what class you're in, and we will discuss these problems and answer any questions you may have. Other than that, have a great night and look forward to seeing you guys later this week. Take care.